Hello. So this is a continuation of our demonstration that we started last time, looking at how to configure a Modbus TCP Master or Modbus TCP client in Codesys on a Windows SoftPLC. And in the previous demonstration, we saw one of the approaches that you can take when configuring the master or the client. And we looked at Modbus server channels. We saw how we can configure these channels, and we looked at the limitations for the channels. For example, just as a recap, we said that each channel defines one Modbus function, and it also defines some trigger methods here, 3 of those. And we said that these limit you to what you can do. For example, defining only one function for a channel is kind of a limitation. So that means that for all the functions you want to do, you have to define each channel for that function. So there is no flexibility here. For example, if I define this as reading 4 registers, I can't change this during runtime. So it's written in stone. I can't change it during runtime. And this is the limitation that we want to overcome. And we said the other approach, apart from channels, is using function blocks. So function blocks give us a lot more flexibility. We can change the read-write parameters during runtime, and therefore we have more control of over our communication there. So as you saw last time when we are setting up this Modbus TCP client, we said that we attach a Modbus TCP client object to our Ethernet interface, and then under that we attach servers. So you can attach as many servers as permitted. For our case, we only have one server, so that is why we attach one server here on that Modbus TCP client device. And we say that when you do that in your library, you will have automatically added in the library manager this IO driver Modbus TCP library. And we can explore a little bit of what that library contains. The library has some special types. We shall see whether we need these and where we need them. It also has a list of function blocks doing different functionalities. For our case, we are particularly interested in this ModbusRequest function block. Let's see what the structure of the function block and the different parameters that are defined with this function block. So if I go to the graphical view here, you'll see that we have different parameters, different input and output parameters. I can go over this quite fast. The slave refers to the slave object or slave device you want to communicate with. Remember, we say that on the Modbus TCP client device, you can attach multiple slaves, so each representing one remote Modbus TCP slave. So that would, this parameter here would refer to which slave you want to communicate with. The execute triggers the execution of the function that is defined with the function block. So on the rising edge, the execution will start, and then when it's done, then it will stop, and the done flag here or done status will be set. Or if there is an error will also be defined here. So there is a timeout, and after the timeout, if no communication has been established or no data has been able to be read or written, then the error will be set here on the output. The abort allows you to abort communication at any stage. The unit ID references the unit ID of the slave, the remote slave. The Modbus command defines the function you want to perform. And remember, all these can be reconfigured during runtime. So that is the flexibility that we're talking about. And we shall see this in practice. The send data and receive data here, these are pointers that point to buffers, that data buffers. So if you were sending data, then your data will be put in a buffer, and then we pass the pointer to that buffer here. And then when we're reading data, then we need a buffer where we'll store that data, and then we pass the pointer to this parameter as well. Busy, done, error, those are statuses. They indicate the status of the function block, and aborted as well. And then the Modbus error here gives more details or more descriptions if an error occurs, so you know exactly what happened. Is the remote slave down? Is the register undefined, and things of the kind. But let's go ahead now that we know which function block to use and the different parameters that we need. We can go ahead and define an instance here. So I'll come here and say MB, or rather FB, ModbusRequest. That is my function block instance, and it's of type ModbusRequest. Okay, now I can go ahead and define all those parameters that we've just looked at. So if I'm working in structured text, I'll come here and then start defining those parameters there. But usually what I want to do when I'm working with function blocks is I use a more visually oriented language. And one of those that I'm usually interested in is this continuous function chart, because it kind of displays the function blocks in a kind of a more visual way, so you can easily see what is going on, and it's more suited for function blocks, as you will see. So I'll call this act representing action, act ModbusRequest, like that, and then add it right there. And then I'll add a box here. I'll define the box of type, so I know the type here, the function block name. So I'll go ahead and say this is ModbusRequest. And then on top here, I'll define the instance. So it's FB ModbusRequest. And then after that, now I can go ahead and start attaching the inputs and then the outputs as well. First, I'll do the inputs, and then I'll do the outputs after that. And then I'll define the different variables that are attached to the function block parameters. Okay, that's all the inputs that I need, and then I'll kind of do the same thing for the outputs. Okay, two more. Okay, now I can start attaching those variables. I need first to define them and then start attaching those. But I can start with the slave here. I don't need to define this because it's already defined here. So I can just come here, browse, and then go under IO config globals, and then I can find my Modbus TCP server there. If you have multiple servers, they'll all appear here, as long as you define them under the tray here. So you will find them all here, and then you can select which one you want to communicate with. And then now I can define these different variables that I need for the function block. So have execute, for example, of type bool. Then I have exabort, also of type bool. Then I have the unit ID, so it's of type unsigned small int. Then I have Modbus command. This is a special type, as we saw earlier on in our variable. We have this type here called Modbus command. This structure defines some variables here. So read offset, read length, write offset, write length. But it also goes ahead and defines the different function blocks, or rather the different Modbus functions that you can perform. That is these are all the function blocks. Sorry, my bad. These are all the functions that you can perform with our Modbus protocol there. So all this is defined in that structure. So you must define a function you want to perform, and then also you have to define the if you're reading, you define the read length, read offset, and then write length, and then the write offset as well. So go ahead and define that as well here, or declare that as well here as a Modbus request, or rather Modbus command. The other two variables we need here, or three, okay, two. We need two buffers, one that is going to contain our read data, and then one is going to contain our write data. And then we shall attach the pointers to those buffers here. So basically, when it comes to buffer, the size should be greater than or equal to the number of registers you want to read or write. So that is kind of the rule there. So for example, if I'm intending to read 4 registers, that means my buffer should be at least of size 4. So I'll go ahead and define those 2 buffers here. So array of read data an array of for our example here, we are only reading 4 registers, but I can define that as an array of, for example, 10 of word. And then I'll do the same array send data. That is an array. Again, I'll go for 10. All right, that's 11 actually, not 10. So from 0 to 10, that is 11 registers of word. And then I have the statuses. Here I have the xbusy, of type bool. Then I have the x done, is also bool, and then I have the x error, is also bool. And then I have the error, Modbus error, which gives more information about which error has occurred. So this is of type Modbus error. Actually, the proper type here, we can find it in the library. So if I come here in the library, you'll be able to find it. So it's yeah, right there. So it's MB error codes. That's the type here. So I should have the correct type here. So it's MB underscore error codes. Yep. And now I've defined all the variables that I need. I can as well indicate here that these are inputs or in out, because we have we have only one in out, and we've not defined that because it's already defined. So I can comfortably say that these are inputs and then these are outputs. Okay, we've defined. Now we can start attaching those here. So for the execute, we know that is x execute. For the abort, we know that is x abort. And then I will also find the unit ID here. And then we have the Modbus command. We have now it's a pointer to the send data. So correct that to this buffer here. So go ahead and get the address of that buffer and then pass it to that parameter there. And then for the received data, again, it's the same thing. The address of that buffer. And then we're done with the output, with the inputs. And then something for the outputs, you have the xbusy, have the x done, or the x error. And then we have we did not define the aborted. I think could go ahead and add that as well. And then we can touch that. And then lastly but not least is this Modbus error. You can just copy it directly from here. All right, so we are done. We've defined all the inputs and the outputs, and you can see why I love working with a CFC when it comes to function blocks. It gives you the visual layout of the function block, the inputs on the left, the outputs on the right, and you know where everything is at any one moment. Okay, now we need to define a few things. We can trigger the execution during runtime. That is quite okay. But we need to define the unit ID, and then we need to define the Modbus command that we want to perform. Actually, we can define all these during runtime, so it shouldn't be any issue. Actually, let's upload this program, and then we can define one at a time, and you'll see how this method brings out the flexibility that we were talking about. So we can define everything else during runtime, so it's completely okay. So first, I'll come here just to make sure that my PLC is running, my SoftPLC or runtime is running already. So see, it's in stop mode, so I'll go ahead and start it. And then I will attempt to connect to it. I come here, scan network, I find it, select, I enter my username, and then I enter the password. And then I can go ahead. I forgot one thing. So since I define this action here, it will not run unless if I call it here in the main program unit. So I'll call it here. Now everything should be complete. I will go ahead and upload this program. And then in the meantime, I can show you, like I did last time, what we have on the server side. So on our server, we have this virtual joystick. And whenever I move this joystick, it gives me these 4 values here: the X and Y positions, the length from the origin, or call it the radius, and the angle with reference to 0. So you can see as I move it here, all those values are changing. And then it tells me where the joystick is, X and Y positions, the radius from the center, and also the angle from the origin. So this is the data that we are sending over Modbus, or the master will be reading over Modbus. Okay, now that we are running, I can go ahead and start here on this master side or client side. I can go ahead and start to define a few of these variables. I'll start with the unit ID. I want this to be 1. Then I'll go ahead and set the command here. The function code, I want to read holding registers. So I'll change this to read holding registers. I want to set the offset here is 0. Offset is kind of the starting register or starting address. And then the length is 4 because I have 4 registers that I want to read there, which contain our data. And that is it for the read part. And now all I have to do is to trigger the reading. So it's the same thing here. If I can come here in my action where I've defined this function block, you can see I have the unit ID set there, the command and everything. Then I can set this execute here to true. And that should read for me some data. And then you can see now it's done. And if I come here and check my buffer, it should have some data in there. Actually, one more thing we can do is we can try to read in a cyclic manner here. So what I'm going to do is I'm going to define, I'll add the util library here, use a blinker to read data in a cyclic manner. So I'll come here and say, this is my blinker. Like that. And then I'll define it down here. Enable is true. Then time law is I'll set that to 1 second. Then time high, also set that to 1 second. And then the out, now we use the out to trigger. So that will be the execute. So what happens is we set the execute to, actually we can set the time load to a longer period. And then we can set the time high to even a shorter period. We can use some milliseconds. So we trigger the the execution by setting this execute variable to true. So whenever, but every 30 seconds we set it to true, so we trigger the execution and then we read data, and then we wait for 30 seconds, we trigger again, and then we read data, and so on and so forth. So that would give us kind of a cyclic behavior there. And I can go ahead and update this. Run. So now you can clearly see that for every 30 seconds we trigger and read data, trigger, read data, trigger, read data. Then you can see read, execute, done, and then now we can observe what we have in our buffer. So this is our read data buffer, and then I can start moving the joystick here. I put it around here. Let's see if we can have both screens, or both windows rather. And what I want to do is, okay, put that one there and this one here, and then, okay, we have the joystick here. So we can have both windows in the same screen. So observe what happens in the read data buffer there when I start moving the joystick. Oh, one more thing that I need to do is, because I've loaded the code one more time, is I have to define these the Modbus function or Modbus command once again. So I want to read, offset is 0. I want to read 4 registers. Like that. And then I want to, the function itself is reading input registers, or rather holding registers. Okay. That is defined again. Now we should be able to get our data as is expected. So bring back this window here. Now I start moving the joystick. And now you can see that we have the data there. So every 30 seconds we get new data. So as I move the joystick, if I take it back to 0, then we should have zeros everywhere. And then if I take it, start moving it, then we should have new data there in our buffer. So if I wanted to write data now to the output, or rather to the server, that would be really simple as well. I don't have to stop my program. I can do that. I can modify all the parameters during runtime. For example, now I want to write multiple registers. So I can set this to write multiple registers. And then all I have to do is define the offset of the start register. I can start from register 5, and I want to write 4 registers. Now all I have to do is put the data in this send data buffer here. I want to put here 200, 201, 202, and 203. That's the data that I want to write on this to the server. Then I can come here on the server, can log out. I can define a new buffer here. I can call it array of data. Sorry, I don't know why I used the comments. So array incoming data, that is an array of 4 registers. And I can specify the address of the start register. Sorry, so it's at %MW4. That means that the data that is that this master is writing to the server will be observed in this buffer here, because it's been mapped to the correct address there where the server is writing the data, where the master is writing the data, sorry, not the server. So that should do it for us. Go ahead and upload this code one more time. Okay, code has uploaded. Run, and now we can observe what we have in there. So you can see the data that the server is writing right there. You can change that. Sorry, I meant to say the master is writing, not the server. So I'll change this to 300, for example. 301, 900, 9000. Write that and then come back here to the server, so you can see that that data is now written correctly as is from this master side. So that is kind of it. You can configure what you want to do during runtime, unlike with the channels where you can't modify anything during runtime. For this approach, you can easily modify or redefine the function you want to execute during runtime quite easily. So that is the advantage of using function blocks over channels. So that is it for this, and let's meet next time for another tutorial. Thank you. Have a nice day.